That's okay. So everybody can hear now, so
Oh,
um,
should I not have?
yeah, that's okay. Yeah, okay. We're going. Um, Good morning. This is the second session of August for DBA Fundamentals. Today's session will be beginning admin, the care and feeding of SQL Server with Jen McCown. Um, I'm your host, Steve Cantrell, along with Glenda Gable and Kevin Wilkie. Shane's not here today, but anyway, let's continue. Our host, or our sponsor, Century One, has some great products. Here's some links to some of their products. There's lots of free stuff on their website also. But while you're looking around at their other products, one of the things I would suggest would be the Plan Explorer. It's a fantastic way to look at execution plans. It's a lot more understandable than Microsoft's. Try that out. It's free of charge. You'll really appreciate it. DB Watch is another sponsor that we want to start working with a little bit more in the future. We haven't had a chance to review their software, so we could talk about it, but you can go to dbwatch.com and look at their freebie stuff also, and also their products. Virtual group news, as always, and we're always pushing the streaming codes because we want to give away sessions, pass Summit sessions to everybody. I think right now we've accumulated one, and we're trying to get a second one. The way we do that is we offer everybody, all the local user groups and the virtual groups can give you $150 discount codes. What we do is we put you in a pot, and at the end of probably around the middle of September, and we'll draw out one person, and one person will get a $500 Amazon gift card, or either Visa. They may be changing over to Visa because it's supposedly easier in other areas of the world to utilize it. But anyway, there's our discount code, VGDISM843, or you can actually get streaming sessions of all of past Summit 2017 if you use that code. If you want to register for our sessions, if you want to register for them all at once, you can go to dbafund.org and go select from all of our sessions that are available and register for one or all. Upcoming SQL Saturdays. SQL Saturdays are really good sessions, day-long sessions, to where you have multiple topics given by speakers ranging from beginning speakers all the way to advanced. But this is where a lot of people get started. But all of the sessions are for free. Usually you'll wind up paying for your lunch, and that's about it. If you'll go to SQLSaturday.com, you can see if there's any sessions around you right now that are coming up in the near future. I've got some older dates on here, but there's quite a few coming up in the near future. Check that out. That's definitely worth it. It's a way to meet other people in your area, and there'll be lots of job recruiters there. So instead of getting their emails, you can talk to them directly. So anyway, try those out. Here's some upcoming virtual group webinars. Saturday Night SQL is going to be having in September a great one with Brent Ozar, getting better query plans by improving SQL's estimates. We'll be doing one in September. Data types do matter. Now that's the down under section of our chapter. In September the 18th, we'll be doing one with Linux fundamentals for SQL Server DBAs. Well-known gentleman in Oracle and Linux circles is Charles Kim. He'll be giving that. PASS has multiple virtual groups with lots of different topics and lots of different languages. So go to PASS's website and check that out. We will be recording the sessions, and they'll be available at in our archive section probably a day or two after the session. You can go to dbafund.org, or you can go to our YouTube channel and subscribe there, dbafundtube.org. Today we have Jen McCown. Her and her husband have a company. I'll let her talk a little bit more about it, but it's her website is midnightdba.com. They have their own utilities that they work with, and have other products that they work with. She's well versed in everything DBA and how to develop the products and how to utilize them. I think you're going to really enjoy this session coming up. I'm going to swap over to you now. I know that wasn't a great introduction. I'm kind of still.
Oh, it's fine. I'm comfortable bragging about my stuff, so it's fine.
Okay. Let's see. Here you go. I don't know if I've had plenty of coffee today. I don't know what it is.
Everyone I've talked to today is really tired. Maybe it's something in the air.
Okay, let's see if we can get you. There you go.
Awesome. All right. You can see it okay?
Looks good to me.
Perfect. Well, hi, everybody. I'm going to presume there are hundreds, if not thousands of you out there waiting with bated breath for the session to begin. So thanks for coming, everybody. And in such big numbers, I'm flattered. So yeah, this is beginning admin, care and feeding of SQL Server. I'm Jen. And yeah, the brag screen, what we call the vanity screen, I am a Microsoft certified master, and I drop that into as many conversations as I possibly can, because that's a neat thing to be able to say. We do have midnightdba.com. That's our training site. It's tutorials on SQL Server and PowerShell and all kinds of different things. And we've been doing that for years and years. It's all free, and it's all open. There's no login. There's no ads. We've got a couple of links to our other sites, but that's pretty much it. So that's, yeah, I encourage you to check that out. Our consulting arm is Midnight SQL Consulting. And then as far as the software that he alluded to, our software company is Minionware. You can find us at minionware.net. And I'll be mentioning, but not concentrating on, our free modules today. We've got reindex backup, and not shown is CheckDB. The Minion Enterprise is our flagship product, so I won't be talking about that today. But catch me online, and I'll talk about it all the live long day. All right, so what are we talking about today? We are going to run through what I consider the big five as far as taking care of a SQL Server. It's an interesting thing to me that we've got, here in the USA, we do have college programs to become a database administrator, but those programs are often platform agnostic, or it focuses on Oracle or what have you. And like any academia, almost any academia, it seems to focus a lot more on the theory and the math and the so forth. This is what I wish we all got a class on when we first get in touch with databases in any way, because these are the things I consider the most important. If you're going to have your hands, if you're going to be in charge of a SQL Server instance of any kind, this is what you need to know. Now, performance is not on this list for two reasons. It deserves to be on this list, but 5 is a rounder number than 6, for one thing. And the other thing is that would just make it way too long of a session. I mean, that, including performance on this, doubles the session length. So keep that in mind, is once you get through all of these, the next thing you've got to think about is making sure your databases, your instance runs well. Oh, well, there's the screen for that one. What about performance? It deserves to be on here. I will point you, if you've never done anything with performance, to Grant Fritchie's book, and I'll have, I believe, a recommendation at the end of the slide deck. All right, so these big 5, why are they here? These are critical and very often overlooked. I mentioned college courses and academia and all that. Almost nobody I know had database classes in college, if they even went to or finished college. So we don't get that initial thing of, here are the things that you really need to watch out for. So they get overlooked, right? You realize at some point in your database career, oh my gosh, I should really be paying attention to alerts. That's totally a thing I should be looking at. I consider anything better than nothing because we are at such an informal path to becoming a DBA and being a DBA that if I go into a shop and they've got anything for these fives for backup, CheckDB, index maintenance alerts, and whatever the fifth one is, I'll have to go and look at my list. Anything is better than nothing. Having said that, it would be a good idea to put in a little bit of effort because while anything is better than nothing, something of better quality, well, we'll go over more of that. And maintenance plan sucks. Yeah, I realize that kind of contradicts point two, but the built-in maintenance plan feature in SQL Server, I am not a fan. If for no other reason that they randomly stop working and don't tell you they're not working anymore. I'm not kidding about this. It's happened time and time again where I'll go into a shop and they'll say, oh, it's okay, we've got all that covered with maintenance plans. And I'll go and look and see that it hasn't run in 8 months. And they're very surprised. Yep, maintenance plans just, they stop working randomly. There are other things I don't like. I don't like the graphical nature of maintenance plans and I don't like the logging. But this is not a maintenance plan suck session. This is a care and feeding of SQL Server session. So of course, the first thing we're going to talk about is backups. And while this may be recap for some of you, I have also, well, I found myself that it took years to really cement into my own head the principles of backups and what you can do where and why this and not that. So we're going to talk about it anyway. I'm going to take a breath and see if there are any comments so far and take a drink. And hopefully not pour it on my laptop again. Nothing going on? Everyone's good? Okay.
No questions yet, nope.
That's perfectly fine. So why do we back up our databases? So, well, backups are, they make a copy of your data or of your log records. We'll go over that specifically. Doing this is absolutely excellent for disasters. A disaster can include everything from losing power, a motherboard going out, a SAN going out, a data center going down, a network problem, just all kinds of stuff. So having a copy of that you can put elsewhere and then make the data available sounds like a really great idea. Other kinds of disasters are man-made, including, somebody accidentally, drops a table or deletes all the credit card numbers in a table or anything like that. Don't ask me now how I know about that last one. Backups are excellent for making copies of your database to put into a QA or a development environment for testing or so that the devs can play around with, what direction should we go in next. A database itself has one or more data files and a transaction log file. While it is technically possible to have more than one transaction log file, nobody recommends that. Don't do that. A database also has a recovery mode. In SQL Server, those are full, simple, and bulk logged. We're mostly going to talk about full recovery mode today. With all that we have to cover, we don't have time to go deep into recovery modes. So your full backup backs up all of your data in the active part of the log. So that is literally, I could lose this entire database, and as long as I have a full backup, then I can recreate that database as of the point in time where I took the full backup. A differential backup only backs up the changes that have been made since the last full backup. There are little markers within SQL to say, okay, this page of data has been changed, so when we take a differential, we get a copy of that. Okay, I have to, you'll have to forgive me, I have to pause for one moment. Give me half a minute. Be right back. Okay,
During
sorry
this
about the
moment,
interruption. Yeah, please go ahead.
that's all right. I was just going to take a few minutes to do some things while you were away, but you're back. Go.
I'll keep going, and if anyone asks about it, I'll explain later. But so yes, so the differential says, okay, here are all the things that have changed since the last full backup. Obviously, a differential backup is not going to be useful by itself. You'll have to have the differential and then the full backup as well. We'll go into this in more detail too. And then the log backs up everything that happened in the transaction log. So if you're not clear on the difference between the data file itself and the transaction log, the data file has data in it, right? That's got your tables, your objects, your procedures. The transaction log keeps a record of every action that affects the database. So an update statement, a delete statement. It does not log select statements because that has no changing effect on your database. Let's see. All right, so backup syntax is really easy to learn and simple. Okay, well, this is the full spec. You don't need to know all of this. What you really need to know is just this, the common backup syntax. So backup database and your database name, to disk, and then the disk location. And I'm adding init and format for a reason. I personally like to always back up with init and format, and I'll explain what these mean in just a sec. So up at the top, that's our full backup syntax. The center one is our differential, and really the only difference is I've named the file differently, and it says differential at the end. So that's pretty nice. And then the backup log, we've got backup log, database name, to disk equals. Now, up here we've got the file names .back, and then the transaction log.trn. That's not a requirement. You can append any extension to your files, but it's fairly traditional to do .back and .trn for the different file types. I've seen some people do .diff. I don't really care. Just so long as it's clear, then I think it's fine. So init and format, if you were not to include these, if I were to run that backup database statement at the top and then run it again, that file, mydb.back, would have two backups in it. You can have multiple backups within a single file. Init and format prevents that. I believe init initializes the header. I may have this backwards, by the way, because I always use them together. And format clears away any existing backup within the file. So while you certainly can do multiple backups to a single file, again, it's the restoring from that is slightly, it causes me to do slightly more typing, and I don't like that. And I don't like the idea of potentially building up a really, really big backup file that's hard to copy or move or what have you. So there. And restoring is very, very similar. And we're going to do a demo of this in a sec. So restore database from disk, restore database from disk for the differential looks exactly the same. And restore log. This is pretty easy, actually, come to think of it. All right, so it's demo time. And I will pause here for a moment and say, this is my favorite piece of art I have ever put in a PowerPoint presentation. And I don't think anyone else is impressed as I am. That's just, I don't know, it's such a lovely piece of art. Okay, so let's go to, there we go. Let's go to our demo. If you can't see the SSMS window, then somebody needs to verbally wave their hand wildly. And I see there may be a comment, maybe? Okay, somebody's recording? Okay.
No comments yet.
Got it. All right, so we're going to demonstrate backup. So I have a database called database one. Let's say this is people are using it, they're churning and burning. We create a table and insert some values within that database. Okay, so now we've got a table with a row in it. Very simple, that's nice. Let's take a full backup. We don't want to lose this highly complicated and full of database. So we back up database DB1 to disk with init and format. And I've also appended stats equal 10 on here That's useful for a really large database backup. It'll tell you this much done, this much done, this much done. This is a tiny database, so it didn't really matter here. We're already done. But there we go. We have a full backup in C/temp. Now, more things happen to our database. There's more data added in this case. And so after a while, we take a differential backup. Remember, differential only backs up the changes. There we go. Now we've got our differential backup. More things happen to our database, and we take a log backup. No, it doesn't have to be in this order. I'm doing this for demonstration purposes. Full always has to be first, but the diff and the log, yeah, we'll talk about that. Okay, so now after our log backup, I'm going to insert a little bit more. So we had some activity, and then we took a full. More activity, took a diff. More activity, took a log, and then more activity, and then, oh no, somebody dropped the database. It's gone. We had a disaster, or someone dropped the table, or what have you. So it's a good thing we had backups. We'll go ahead and restore them. If we restore just a full database, and just like before we saw, restore database DB1 from disk, that's seriously all there is to it. Give it just a minute. There we go. Then our database is back. Yay, and we've got all our data. Whoops, not all of our data. That's right, because we took our full backup just after that first little bit of activity. Now you start to see why it's important to have frequent backups, right? So, all right, then let's go ahead and start over. We're going to restore database. This time, by the way, doing with replace, which will replace the existing DB1. I'm going to caution you most strongly to be careful using restore with replace. Make sure you're on the right server. Make sure you really, really want to replace the database. And no recovery. A database that is being restored and needs more restore actions must still be not recovered. If we go and look, by the way, at Object Explorer, yep, current, and we look at DB1, eventually, there we go, it'll actually say it's restoring. While it's restoring, and it's inaccessible, because we don't want anyone to make changes before we apply all of the backups we want to apply. So now we're restoring the differential with recovery. That'll bring it back online, make it accessible. Okay, now it's up. There we go. So now we restored our full, and we had this much data. Then we restored the differential on top of it, and we got up to that point in time where the differential happened. But we have more. We have more than that. This time, we're going to do all three. We're going to do the restore database with replace, no recovery. I'm not going to bother restoring the differential. I could if I wanted to, but I don't have to, because differentials and log backups work independent of each other. Every action that has happened in the log is recorded in the log backup. So in this, I only need to do the master and the log. There we go. We've done restore database, we've done restore log, we're going to use DB1. Oh dear, it's in the middle of a restore. Yeah, I put with no recovery, so it's still in that restoring state. All I need to do is tell it, oh, well then, bring it online. Restore database with recovery. There we go. Now it's back online. Okay, so you've gotten the demo, but it may still not be clear. I say again, I remember very, very clearly in my early years staying confused far longer than I should have. I shouldn't admit to that, but I'm going to, about database backups and how they relate to one another. So we're going to go back to the PowerPoint. This is a good time as well. If there are any comments, just interrupt me. So we already said a log backup saves off transactions, but more specifically, each log backup saves off all the transactions that have happened since the last log backup. That's important. Each log backup really only pays attention to the last log backup. Oh, okay, well, we need transaction 4 through 10. Good, save those off. Oh, well, last log backup saved through 10, so now we need 11 through 16. Got it. A log backup allows the log file to truncate old transactions. In full mode, a database will keep recording those actions on and on forever, and then your log file gets really big, it fills up your drive, and then you get errors and alerts, and the database is inaccessible. Oops, going back one sec. So yeah, it's very important to have log backups. This is a point of confusion for a lot of people. The log file itself does not care about full backups. Some people are confused and think, oh, if I take a full backup, it'll allow the log file to truncate, to get rid of old transactions. No, it will not. The log file does not care about full backups. Log file only cares about log backups. Okay, to put it graphically, here we have a database. Here's DB1 in full mode. It's empty at first, and then some actions happen. Well, actually, before the actions happen, we take a full backup. Well, our backup is empty. There's nothing in there. Some actions happen, and we have this little blue ring of data. Then when we take a full backup, we've got that data. See how we've got our log file in the gray rectangle, and it's still growing. Action 1, 2, 3, 4, 5, oh dear, still going. We take some more actions happen, and then we take another full backup. We still have all our data, but man, that log file is really growing. So it's not enough if your database is in full mode or in bulk logged. It's not enough just to take full backups. You want full backups and log. So here's the same thing. We start DB1 empty, full backup, it's empty. Actions happen. We back up those actions, those transactions, to a log backup. And then our transaction log file keeps nice and small. See how after that first log backup, we've got only action 4 and 5. Because well, the other ones were backed up. The system was able to say, okay, those have been backed up, I can truncate them. So there we are. We've got our full, a log backup, some more things happen, another full, another log, and another full, another log. This is a perfectly fine scenario. You don't actually need differential backups. I'll show you how they're useful in a minute. They're a nice to have, certainly, but they're not technically like really necessary. So you see from here how the full and differential backup looks an awful lot like just full backups, like only full backups, in the sense that our transaction log file is growing. We've got actions 1, 2, 3, 4, 5, 6, 7 by the end of all this. So the whole scenario would look a little bit like this. We take our full backup, we take our log backup, differential, more than likely in a normal scenario, you'd have a full backup, maybe a few dozen log backups, because we'd do those, maybe every 30 minutes, every 15 minutes, and then maybe once a day or so, your differential. We'll talk about this in just a second. What I want to do is go back to the demo, actually. That's right. If I don't escape out of this, you won't be able to see. So this is what I was talking about when I said we have options. If you're doing full and diffs and logs, let's say every Saturday you do a full backup, every day you do a differential, and every 30 minutes you do log backups. That's a fine scenario. There's nothing wrong with that. And if I had to restore from that, I could do my full restore and then run through all of my log restores after that full. So here's my full, and here's the first log backup that happened after that, and the next, and the next, and the next, and the next, and several dozen more, and then the last one here. That would totally work. There's nothing wrong with that. It can be a little bit of a pain in the butt to either write or generate all of these statements. So that's where the differential can be kind of a nicety. If I do my full and then the latest differential, then I'll probably only have maybe a couple, maybe a handful of log backups to restore. And I will definitely pause and check for comments and questions. Okay, I don't see anything. That's okay. Everybody's just enthralled. Going back to, so just briefly touching one more time on recovery model. If you're in full mode, you have got to take both full and log backups. If you're in bulk logged mode, same thing. If you're in simple mode, you actually can't take log backups. The database will only save transactions in a log as long as it needs to internally. It won't keep them forever. All right. Oh, you know what? I should really say, if you have a database in full mode and your transaction log is huge and you get advice online, oh, just switch to simple mode and back. Understand that breaks your log backup chain. That means you'll only be able to restore to your last full backup. until you take another full backup. Okay, we could go into that, but this is a really long session, and if someone needs that repeated, that's fine. Just let me know. But yeah, it's not a good idea to shrink your transaction log file by switching to simple mode and back. Just take a transaction log backup. That'll do the trick. All right, so bottom line for backups: schedule your backups, both full and log. Use native SQL Server backups as much as you can. I've got clients on Avamar. I don't care for it for a whole number of reasons. Again, I'll be happy to talk with you about that offline. I'm not picking on Avamar particularly. I really don't like any third-party backup solution that doesn't use native SQL backups, that uses a proprietary format. If you're setting up your own system, log your backup activity. I did say I would mention our tools. Minion Backup is free. You can go download it. All the code is open and free to look at. It logs so much information, and that can be very, very useful to help track down performance and errors and just all kinds of stuff. Age out old backup files. You don't want to keep those backup files forever and ever. You're going to need a whole lot of space. And alert for missing backups, not for failed backup jobs. Because if let's say that your backup job just doesn't run for a while because SQL Agent is off. You won't know if you don't go looking. So we'll talk more about alerts later. Let's see how we're doing on time. Awesome, perfect. The backups is really the biggest section, and I put it first. I don't know if I'd call it the most important, but it's pretty darn important. All right, so integrity checks. Why do we do this? Why do we check database integrity? Well, what actually happens is when the system, when the OS writes to disk, it can be written incorrectly. Not very often, but every so often it gets written incorrectly or mixed up once it's on there. Sometimes there are fundamental issues with the disks you're writing on. That's called corruption. It corrupts your data, so it doesn't actually make sense to the computer or the SQL Server. Corruption does not give you any warning. It's like, I don't know, it's like corrosion in your engine, right? It's not like your car will suddenly speak and go, excuse me, we're having some corrosion issues. No, you pretty much find out when something starts running rough or falling off, right? Same thing here. Corruption happens, it gets prevalent, and then your system won't work anymore. So you need to check often. This is very vital maintenance. If you do not check, you will lose data. There's just no way around it. Okay, so we've got 3 different scenarios going from best to worst. And well, you know, the best case for scenario, of course, for corruption would be not to have it. But barring that, the best case scenario is you've got regular integrity checks going with alerts, and the corruption that's discovered is very mild. That's the nice, easily fixable kind. If you, for example, an index is corrupted, then you can just rebuild the index. No problem. Corruption is fixed. Okay, so that's the good scenario. The not so good scenario is you have regular integrity checks and alerts, so you find out right away when corruption is found, but it's the bad corruption kind. Microsoft recommends your first order of business is to restore from backup. Now, think about that. You're supposed to restore from backup if you've got the bad corruption. That means it's really, really nice to know about the corruption right away so we can keep as much data as possible. Like not have been backing up corrupt data for the last 3 months and then find out about it. And have to lose 3 months worth of work. Yeah, that happens. That's the last scenario. You don't have any integrity checks, or you do, but you haven't bothered to alert on it, and that information just goes to the log file. Yeah, that's when you're in deep trouble and you're going to lose tons of data, and people are going to be digging through the actual data pages with files and with tools, and that's the bad. We don't want to do that. That's a resume generating event, is what they call that. All right, so recovering from corruption. Like I said, the best, quote, best one is index corruption only. You can drop and recreate the index, no problem. Next worst, you can do restore from backup. That's the most recommended by Microsoft. The next, quote, best solution is to run a CheckDB with repair rebuild, and we'll look at that briefly. This option does not allow data loss. It'll fix it if it can, And if it can't, it'll leave it alone and tell you so. Now, repair allowed data loss is kind of the court of last appeal. It's not good. You're going to lose data. This is, by the way, one of the best named things in all of SQL. We're going to repair it, but you're going to lose something, I swear. All right, let's look at CheckDB real quick. Oh, that's right, got to escape out. So CheckDB is pretty simple to run. dbcc CheckDB, and then your database name. No problem. If we ran this, it would go and run the entire check on master. Right now, we're going to use the with estimate only, just to find out how much space is this going to take if I run the actual operation. Well, it's not going to take that much space. Where did it go? Estimated in KB is, that's about 14 megs, a little less. Well, yeah, master is tiny. It's not going to take up that much space. So we can run a CheckDB on master right here live. Let's see if we have any corruption, shall we? While that's running, I will note that you've got the option to do physical only. This is a lighter version of this. And this is for when we've got, we're only allowed to do the full CheckDB, say, on the weekend. That's the only time. But I've got important databases I really want to run daily, then I can at least do a lightweight check throughout the week, right? This is not a replacement for a full CheckDB operation. Just wanted to stress that. So, all right. If we wanted to run repair rebuild, if we found, oh, wait, we never looked at the results here. You can scroll way down to the end. CheckDB found 0 allocation errors and 0 consistency errors. This is what you're looking for right here. 0 and 0 means all is well. Awesome. If I wanted to run, if I'd found some corruption and it wasn't in an index, there is a process for finding out where the corruption is, but we can't get into it today. Google it. It's great stuff. We could do, like I said, the best option is dropping and recreating the index or backing up, but let's say neither one of those is an option for me. So, okay, fine, we're going to try and run repair rebuild. This is how we would do it. And then if you wanted to do repair allow data loss, okay, if you had to do that, this is what it would look like. We're not going to do that today. Just wanted to show you what it looked like. All right. So, all right, bottom line integrity check. Schedule frequent checks. Again, in my mind, there's a kind of a standard weekly full checks and daily physical only for important databases, including your system databases. Log the results in SQL if you're creating your own system. And here I mentioned Minion CheckDB, which again, completely free, all native SQL. Open it up, look at it, logs tons of information and does all this on a schedule for you. And alert on the results. When you run a CheckDB, here, let's escape out of this. When we ran that CheckDB by hand, we got the results back in the window, of course. When you schedule a CheckDB operation in a job, it writes the output to the SQL Server log file, like the error log, you know? Well, I don't want you to put on your daily checklist, go to all of my instances and look for corruption errors. No, that's not good. We got to alert. We'll talk more about alerting. Like I said, that's one of the big 5. But it's very important that you both do the checks and alert on the results. And make sure you have regular backups, okay? We've already sort of demonstrated how screwed we would be if, we have corruption and we alert on it and we haven't had decent backups in forever. All right, index maintenance. Your indexes get naturally out of order, okay? So the basic operation is, you've got a table, you've got an index on, date of birth, right? We need to insert a new row. Well, SQL goes to that page to see where that belongs, sees if there's any room, and if there's no room, it'll split part of the data off onto a new page, and it won't necessarily be contiguous on disk. It won't necessarily be right next door. So getting all the data mixed up on disk is called fragmentation, and that can make things go slower. People have debated and done tests and so forth on how much slower fragmented indexes. And some people say, oh, it's not that important. Some people say, yes, it is. I'm in the yes, it is camp. You can do your own experiments if you like, but yeah, go ahead and do index maintenance. So we already talked about this. So data is stored on pages that are 8 kilobytes big. They can split if a page gets too full. This is very like, I like to think of little librarians and shelves full of books in the library. If I've got a shelf completely full of books, say it's my Stephen King shelf, right? And King writes a new novel, because he writes a new novel approximately every 8 months, bless him, and it's an M, then it needs to go right smack in the middle of that shelf. Well, the librarians are busy people, and they're very desperate to put the book where it belongs, but they don't have the room. So they take half the books and they stick it somewhere else in the library, and they leave a note on the shelf that says, Stephen King books N through Z are on the shelf over there. That's exactly what SQL does. It splits out that data. And running around to find all the King books is eventually going to take a lot of time. All right, so we defragment. And what's more, we try to prevent that fragmentation. So I'm trying to decide if we talk about this in the demo or if we talk about it here. We'll just mention it here. So we basically need a few things. We need to find out how badly fragmented. If I walk into the library and they say, oh, the Stephen King books are on these 16 different shelves, that's some pretty bad fragmentation. They need to prevent that, and we'll look at the fill factor and pad index options. As far as maintaining the index, you can reorganize or you can rebuild your index. And I think of this as reorganize is lightweight. And that would be where you go to the shelf and you say, you know what, okay, we're gonna put half of these back on here and we're gonna make sure they're in alphabetical order and so forth. Rebuild is you take everything off the shelves and then sort it and put everything back on the shelves. So we've already done the check DB. So that thing I said we need to find fragments. Let's go in here to a DMV called DMDB index physical stats. While descriptive, it's kind of long. So we pass in the database ID. We're currently in Minion. And what I want is to find the fragmentation, what percent fragmented is this index, if it's more than 10% fragmented. And page count, I put page count greater than 100. You could just as easily put page count greater than 500 or 1,000, because little tiny indexes don't benefit a whole lot from index maintenance. It's just not that big of a deal. If I've got a table or an index that's like 5 pages long, they're not going to get all that out of whack. All right, so I find that in this database, I have a heap, which is the table itself. The table does not have a clustered index. And the table itself is fragmented pretty badly. And it's still a small table count, but this page count, but this is a demo database, right? Okay, so we found one. Then we could go in, I'm gonna skip down here, and rebuild that index. Or we could, somewhere down here, I have reorganized that index. We're going to go to DB1, create an index on table 1. That's that one we created at the very beginning. And let's say over time, table 1 gets a lot of activity and that index gets nice and fragmented. So we say, okay, well, it's a little fragmented, so I'm just going to do, and we don't have a lot of time today. I don't have a big maintenance window. So I can alter that specific index on that specific table to reorganize it. Or I could choose to reorganize all indexes on that table if I really wanted to. Okay, no problem. We'll reorganize it, no big deal. I need to get a bit of fragmentation, but that's not going to happen today. Or we go in and we find, oh, it's very heavily fragmented. And by the way, the difference between lightly and heavily fragmented is a little bit subjective, but I would say lightly fragmented is 10 to 20% fragmented, and then that's 10 to 20% stuff out of order, and then 30% or more is heavy enough that I'd like to do a reorganize. So all right, same exact. Do a rebuild. Rebuild is for heavy. So we could alter index on table 1, rebuild. Cool. You do have an option. Reorganize is an online operation, meaning that it's still accessible during that operation. Rebuild tends to be offline, but under certain circumstances, it can be online. But you got to go read about it because it's like an if this and if that and maybe that and this version. We're not going over that today, most definitely. All right. Oh, look, I did do a nice little demo, so we can put this in and then fragment it and see how it goes. I had something else to talk about while that was running, and it's gone right out of my head. Right, fill factor and pad index. This is why I write these things out in advance. All right, so back to the library, right? You know for a fact that Stephen King writes a lot of books, and he does not write them in alphabetical order, more's the pity. So what we would do then is we would look at this shelf and go, you know what? I bet this guy's going to come out with at least 3 new books by 2020. So when we reorganize or rebuild, rather when we rebuild the shelf and we take everything off and put it back on, or better still, when we first load those books up into the shelf, we say, you know what? On each shelf, I'm going to leave a little bit free to make sure that I've got the space for it. So this shelf can hold 20 books. I'm going to leave it 10% free. I'm only going to put 18 books on here. That's fill factor and pad index. Fill factor says, fill up my index to 90%, leave 10% free. And pad index, this has to do with, hang on, let me see if I can get it straight, because this is one of those things that I have to look up all the time. Yes, I know I'm a certified master. It means I've got lots to remember. Google is your friend. But pad index, if I remember rightly, says go ahead and apply this fill factor to every level of your index. It has to do with, if you're not familiar with it, an index is structured in a B tree where each item forks off and points at 2 other items and so forth down to the leaf level, which actually contains the values. All right. So fill factor and pad index is your preventative, and you can apply that either when you create the index and or when you rebuild it. All right, so we've created table 2. We're going to look at fragmentation for that particular table. Hey, look at that. It's not very fragmented at all. It's got 50 pages. Cool. Now, what I've done here is we've created this table with an identity key as the clustered index. What if we've got a unique identifier? You know, unique identifiers are these big, long, here, let's go ahead and fill this up. These big, long, what is it, 16-bit? 16-bit byte? Yeah, I should really write that down too. Values that are generated randomly. Now, if you use a unique identifier as a clustered key, it's going to get really, really fragmented because, again, those are random values and you're sorting that primary key, that clustered index on a completely random value. That means we're basically flinging library books hither and thither and yon. So there's going to be a lot of page splits. There we go. And when we go and we look at the table that has the unique identifier, it's going to be extremely fragmented, 98%, as opposed to those same 20,000 rows in table 2, 3% fragmented. I'm just saying it's a really good case for not having unique identifier as your clustered index key. All right, we have covered the big 3 of the big 5, but the last 2 are pretty important. Couple of notes before we move on. You can't reorganize a heap. It has to be rebuild. And remember, a heap is just a table that doesn't have a clustered index on it. We already talked, go back, about alter index all, so you can target one index or all of them. We already talked about small indexes. Index maintenance on full recovery mode databases can use up lots of transaction log space. It is a logged operation. So take frequent log backups if you've got a database in full recovery mode and you're doing large reorganizations. So schedule your maintenance, don't do it by hand, and log the results in SQL. And of course, we've got a module for that too, Minion Reindex. Also free, also all native SQL and stuff. I put disk management on here because even though we've got SAN guys that are supposed to take care of this, and even though SCOM is supposed to warn us about disks getting full, I'm not a big fan of SCOM personally, but that's fine, that's beside the point. It's not at all a bad idea for a DBA to keep track of their own disk space usage. So disks get full of database files and backup files. And while, again, it would be nice if the SAN person came to you in advance and said, by the way, this disk is filling up, I have found they don't often do that. So let's take it on ourselves. You can create your own solution, or you can get your company to buy one. Those are the two options. I will show you today, oh, that's right, I need to escape out of this every single time, a very simple template if you wanted to create your own solution. I've got a PowerShell script here where I'm going to basically create a table in SQL, call it disk space, where I can log disk space information. And then using PowerShell, I can gather the disk size and its fullness, how much data is on it, and log that to the table. So once that's done, I can have an alert that says, oh, okay, when any disk gets below, I don't know, 15% free, 10% free, send me an email and tell me. Boom, you've got your solution for disk space. We've got 8 minutes. I think that's enough to cover this in the next thing. So if you're not familiar with PowerShell, don't worry about it. It's fine. And if you're interested in this script, just go ahead and contact me after the session is through, and I can email it to you. But let's walk through it real quick. So we create our table over in, hang on, got to get a new window. We'll go ahead and create that in DB1. So we've got someplace to put it. Disconnected. What's your problem? Of course, the demo gods will get onto my back. All right, fine. Maybe we'll just talk about it, right? I believe that you believe I can create a table. So here we go on the PowerShell side. We've got a variable we call drive list. We use get WMI object with Win32 volume to pick up information about the disks on this computer. This is my laptop, so when I run this, it'll only pick up the C drive. That's all we've got. We pass the disk information, we pipe it to a where clause to filter. I only want fixed drives. That's drive type equals 3, and where name isn't like whack. Those whack drives are internal system drives that we don't have anything to do with. And then we would get our capacity information, free space in gigabyte and free space in percent from that. So this is just pulling back the information and sticking it into what would be a list if I had multiple drives accessible on here. I'll go ahead and set the execution date time because I want to log what time I grabbed this information. And then this says for each drive in drive list, this is a for each loop. There's the beginning, here's the end. We're going to specifically call out, all right, drive letter equals the current list items drive letter, the current list items capacity, and so forth. And just plug those into a SQL query to insert them. And then this is how we run that query. Again, if PowerShell is Greek to you, that's fine. I'm not here to teach you PowerShell today. We can do that some other day. But that's what this does. Grabs the information, loops through, inserts it to that table. If that table were ever to, there we go, it actually got created. So for the fun of it, no, not you. Let's go back to PowerShell. I'll be interested to see if this, I haven't run this in a while. No, it'll be saved, it's fine. Is it going to be the red code or not? Oh, or is thinking about it. Select star from disk space. See if it completed. What you doing there, buddy? Okay, fine. Well, for some reason, but we'll come back to it in a little while and maybe we'll all be very impressed. But once we've got that information in disk space, again, it's to say, okay, if capacity, if free space percent is less than 15, send me an email. Nice, automated, and what's even better is you can track your disk space growth over time. And if there's a steady trend, say you're gaining a gigabyte a month, it'll be easy to predict, oh, by the way, we're gonna need this much more space at least next year, Mr. Sandperson, Mr. or Ms. Sandperson. All right, so that is the briefest of brief on disk space. Let's see if I had anything else. So automate, this is not something that you want to have on your daily checklist. We don't like daily checklists. We like automation. Log the results in SQL. Don't put stuff to flat files. You're not going to go look at flat files. SQL is useful. Flat files just sit there. Alert on your results. We already talked about projecting. When is the disk going to be full? How much more do we need? And as always, whenever you log information, make sure you're aging out old information. You don't want to come back 4 years later and find that you have half a terabyte of disk space information, right? And finally, alerting. And I know we've only got a couple of minutes left. Yeah. Why alert? We've talked about this so much. We alert because we want to know when things go wrong. And by the way, I don't like positive alerts at all. I don't like, this job has finished positively. That's great, but that creates a storm of alerts and it teaches you to ignore alerts, right? An alert needs to be actionable. You know, this has broken, or there's a missing backup and you should go check it out. So set up your database mail, if you haven't already, in the template browser in SSMS. Hang on, I want to see one more time. Is it in there? Is it in there? Dang it. Move this. Wow, there we go. In your template browser, you've got a script to set up database mail. So you would open that up and plug in all the right values, and that kind of simplifies setting up database mail. So that's nice. Alert for at least, this is just a starting list, missed or failed backups. So I actually have a script in the Minuware community zone that goes and checks to see when the last backup was. And if it's been, a week, it's configurable. If it's been more than a week, then I get an email that says, hey, it's been more than a week for this backup. Alert for integrity checks. Definitely if you haven't had one in a while, and most definitely if corruption has been found. In its maintenance, if it hasn't been done, and disk management, if a drive is nearly full, or you haven't been getting information lately. So that's just your starting list for things that you really want to alert on. I'm sure that if you're working with databases right now, you can probably think of half a dozen more. So as always, automate, log the results on your alerts. They should be actionable, should have a broad scope. Broad scope, that kind of refers to, we're not just logging on failed jobs, but this hasn't happened at all for whatever reason. And alert for all SQL Server instances. All right. We already said this stuff before, and I want to leave a couple of minutes for comments and questions, but I wanted to do a quick shout out. Unsplash.com is responsible for the art that you saw on here. It's a free, fabulous service, and so I just wanted to call out the artist that provided that. This entire session was based on my chapter in the book Voices from the Data Platform, which I wrote with 7 other fabulous women in the SQL community. And I think that's it. So I'll stop talking now and let you guys talk or ask.
Really, Jen, thank you very, very, very much. We will get to questions in just a second. I had several asking for the scripts and such. If you can send a question in that tells me that you're allowing me to pass your email address to her, then I can go ahead and do that. I don't have permission to otherwise. So just write a question just saying, yes, I allow you to pass my email address, and I can go ahead and get those to you, no problem. And I know, Kevin, you had a couple of questions to send her way.
I did actually, but I think she actually went over most of them. Make sure here.
Okay, I'm not hearing anybody right now.
I'm gonna go through this question. I think you've answered everything I had.
Just in case you can still hear me, someone said, you said full backups do not affect log backups. Will differential backup reset the log backups? No, the log file only cares about log backups.
I do see a question about your PowerShell that did the drive.
Regular equals what? That really depends on what your system and support. So a good starting place would be weekly for everything and daily for DB, temp DB, and mid would you imagine would
Glenda, is it me or is
stop
Jen
the
breaking up?
database from working
She is breaking up quite a bit.
because
I sent her a
SQL
message, but I don't think she can hear us.
looks over.
I don't know if she can, I don't think she can hear us. The message I sent's the only way to communicate with her. Now I'm not even hear her break up.
Yeah, me neither.
Oh,
Okay, well, we'll wrap things up. Make sure you guys visit dbafund.org for our contact information and upcoming meetings. We do have some September and October, so check those out. Also, dbafundtube.org, which is our YouTube recordings. This will be on there in a couple days or so. I do have all of you guys who said yes. You'll,
Interesting. PowerShell script. I just got audio connection restored, so I'll be interested to see if I can hear you or vice versa.
Can
I
you
will
hear
pass
us?
on.
There we go. Gosh.
There we go. Perfect.
So sorry about that. I've just been
So-
talking into the void.
No, you're fine. We heard robotic Jen for a little while.
Oh, no,
We will pass
no.
on your email addresses to her so we can go ahead and get the scripts to you. And lastly, is there anything else, Jen, you want to cover? If not, we'll let everybody go.
Thank you guys. Sorry for the technical glitches and me probably talking over everybody. And if any further questions, feel free to hit me up on Twitter at MidnightDBA. On the Slack community, I'd have to look that up. It's not a SQL family. What is it? Oh well, I'll post it on Twitter under MidnightDBA. And I guess that's all I've got.
Thank you very much. And thank you everyone for joining us. Have a great day and we'll see you soon.
Thanks a lot, folks.
I'll close it out so
Okay.
we don't get it possibly losing the recording.
Okay. And I'll get the questions.